Greetings everyone, my name is Rudra and today I'm going to be showing you how to integrate MATLAB and Simulink with Prespective using the MQTT networking protocol. So let us begin. You can get the MQTT in MATLAB protocol by going through the MathWorks website, and there is a toolbox that is already available here. You can download it using the zip folder, or you can download the toolbox itself. Instead of this as well, you can maybe make a demo Simulink project where you open the demo Simulink project. I'm using MATLAB 2020b for my demo here, and you can add it as an add-on. You can get add-ons here. So you can type MQTT in MATLAB and you will get the add-on here, and you can download it here. In my case, I've already integrated it in my MATLABSimulink, so it's already a part of my project. So this is how you can include it and integrate it in your project. Now that we have our MQTT in MATLAB toolbox, we can open the Simulink project and we make two MATLABSimulink functions called MATLAB. This is MATLAB function 1 and MATLAB function 2. So we can name this function as MQTT wrapper subscribe and MQTT wrapper publish. As you can see, these are two MATLAB functions that we have created to send and receive values into Prespective. So now it's time for us to set certain inputs inside these MATLAB and Simulink functions. So we can first do it, we can first rearrange them, and we open these and define certain inputs. So we can define the inputs as like this. We take a value, an input that can be published on a particular broker. Then we write the topic that it can publish on. We have the address, the client ID, the port, and the QoS. And we can end this function here. Similarly, we can define the subscribe by getting the topic, the address, client ID, port, and the QoS values. Here we don't have an input because in subscribe we get values from the broker, so we just have 5 inputs, whereas in the case of the publish we have 6 inputs. So this is the setup of the block. Now what we have to do is we need to use the functionality of the MQTT MATLAB toolbox to publish and subscribe values to a centralized broker. But because the toolbox is built in MATLAB, we cannot directly use the functions that are defined inside that toolbox. So what we can do instead is we create separate MATLAB 4 files, the MQTT publish.m file and a MQTT subscribe.m file that does the publish and the subscribe, and then we extrinsically call these MATLAB files inside the Simulink blocks so that they are compiled outside of Simulink. So in order to do so, we can go back to our folder and we create a new script, MQTT wrapper publish.m. We can create a new script, and we can first save it. In MQTT wrapper publish, and we create another script and call it MQTT wrapper subscribe. Yeah, okay. So first we'll work with the publish. If you want to know the functionality of this system, if you want to know how to use these functions, you can do it using there is a help button that is available in those add-ons, so you can access the help. You can open the documentation here, and then you get all the syntax and the semantics that need to be followed while publishing and subscribing to a centralized broker. So we can first try out something from our own site. What we do here first is we have already defined the block inside Simulink, so we can define a function MQTT wrapper publish, which has the same set of inputs: topic, address, client ID, port, and QoS. Then we initialize our client, persistent my MQTT, and then we try to initialize the client. So if is empty my MQTT, we say my MQTT is equal to MQTT TCP plus. So we can get the address from the Simulink block, whether it's a local host or something else. Then we define the client ID, which is the client ID which we get from Simulink, and then we also define the port, which is the port. So this is our definition of my MQTT, and then we end this. Now, when we get inputs from Simulink, the input might be a non-string function. So what we have to do first is we need to encode it into a string so that it can be sent over the network. So what we can do is we do input JSON is equal to JSON encode input. And finally, we do input JSON, and finally we use the publish function, which is publish my MQTT topic input JSON along with the QoS, which is also obtained from Simulink. And then we end this function. Oh, so there's a slight error here. And yes, we have set up the wrapper publish.m function. Now it's time to set up the subscribe function. So in the subscribe function, what we do first is we we make a client, we create a client, we initialize it, and then we have the callback function that is used to call back and get the value that is get the value of the topic that is subscribed. So we can do this by having a class definition. So class define MQTT wrapper subscribe properties return message and return topics, and we end the properties. Then we have a methods definition where we define an object that is initialized using the MQTT wrapper subscribe. The port QoS. Yes. Then we have our own MQTT definition here again. So first MQTT creation, client creation, my MQTT. So we follow the same steps as above. So if as what we did in publish, if is empty my MQTT, then you say my MQTT is equal to MQTT TCP plus the address, the client ID, the port, and the port. Yes. And then we end this. Next, we go to creating another client, persistent my sub, and we do the same with my sub, but this time what we do is we say that if my sub is empty, we subscribe to a topic. We say if my sub is empty, we subscribe to a particular topic which we get from Simulink, and the QoS is and then we use the callback function which is inbuilt inside my sub, dot callback @my MQTT callback. So the function definition of my MQTT callback will be done later below, and then we end this function. So here we are going to define the callback function. You say function my MQTT callback equal to my MQTT we define the MQTT callback with a particular topic and a particular message, particular topic, and a particular message where we print out first the topic and also the message. And we also call the OPG, we assign the return message to the message, and we assign the return topic to the topic we want to. We end this function. There is equal to missing. So now that we have set up this function, as you can see, the output is in MATLAB and not in Simulink. So we will first set up a block inside Simulink and try to connect it, an output block inside Simulink, and try to connect it with MATLAB later as we progress through the video. So we have our publish and subscribe wrapper functions ready. Now we need to go back to Simulink and set up. We need to set up our system. Here we need to call those .m functions extrinsically inside the publish and subscribe. In order to do so, we have to type in two functions. First we do a coder.extrinsic MQTT wrapper publish, which executes outside the generated C code, and this is useful only if the block is used for simulation and not for hardware code generation. So this is only good until you have simulations. Can be only used for simulations. Then we have the wrapper publish, which has the input topic. We call the function again. The port and the QoS. And this basically calls the wrapper function. First, this executes outside of the C code, and then it calls the wrapper function. The same thing we need to do with the subscribe as well. So what we can do is we go to the subscribe and we paste it here, but this time we remove the input and we change this to subscribe. So yeah, this is our system ready. We have two Simulink functions, two Simulink blocks that can get certain set of inputs. Then we execute the .m file that contains all the functions extrinsically, and then the function is called, these inputs are given to those functions, and then publishing and subscribing is done appropriately. Now that our system is set in such a way, we can now set up a Prespective side of the system. So I have the example of a 3D printer that is open here. It has three components, the x-axis, y-axis, and z-axis. And one of the components has a y motor. So we can set up a stepper motor which can be controlled using MATLAB. So if I want to, I can set a driven stepper motor here, and then I can set up the pre-logic component outside of this. So I go to my perspective menu, perspective menu, I go to logic and I add a logic simulator. This is the pre-logic simulator, and then I add the logic component to this. So I create an empty game object, and then I add the stepper motor logic component, driven stepper motor logic, and I parent the pre-logic below. The pre-logic simulator is now a parent to the driven stepper motor logic. Let's change the name, stepper motor logic, which is the Y direction. Now I need to assign the appropriate motor to this, so I assign the Y motor, and this is the pre-logic simulator. Here you can select from a list of adapter type settings. So I select the MQTT adapter. As you can see, it's already set here. I've set the IP address to 127.0.0.1, which is the local host. Then I have the port defined, which is 1883. I can name the simulator as my 3D printer simulator. And I can also have this server name, again your choice, 3D printer. And then I have to export the policy, but before I do that, I need to set up this, because here the naming convention of the variables that need to be published and subscribed is defined. So in order to do so, I need to define this. Everything seems fine. I need to set the PLC path separator, and here I select index in parent. So this defines the name ruling of the components of the variables that are subscribed and published inside of Prespective. So once I do this and I save it, I can export my policy and open the policy file. So what I want to do is I want to send values of the motor from MQTT to Prespective, and then I want to get the position of the y-axis from Prespective onto MQTT. So if you see here, this is how it is defined. Oh, there's a dot here. You need to change that here. And then we export the policy again. And we open the policy file. Yes, now these are the inputs. If I want to see the output, this is what I can send from MATLAB inside Prespective. So here, this is the topic that I need to publish values on, and if I want the position, I have to subscribe to this topic inside of MQTT, inside of MATLAB. So now let's set up the system inside MATLAB. In order to do so, we have to set a constant input, string constant. Here, stepper motor preferred velocity. This is set. Let's expand these blocks because they are quite small now currently. So this is the input. Oh no, this is the topic. The input can be set later. Then we have to set the address. Make another string constant, which is localhost. I need to make copies of this because the address is the same both places. Then we define the client, again another string constant. Let's make it my client and put it here. And we define another client for subscription. Let's make it my client 1 and put it here. We also have to define the port and the QoS. The port is 1883. 1883. And we also need to make the same port number here. And let's keep a QoS value of 1. Yes, so this is our initial setup. We also need to define the topic for the subscription. So we can do this by having again another string constant, and we have to subscribe to this to get the position of the y-axis inside of Simulink. So this is set up here. We apply to this, and yes, this is our setup. Yeah, so this is complete, and I can set up another constant which keeps sending values during runtime to Simulink, to Prespective. Now, as you remember, the subscription values are received. Subscription values are received inside of MATLAB and not Simulink. So what we can do is we can define another constant here inside of Simulink, because the subscription values are received inside MATLAB. We want to have it inside Simulink, so we can define another constant block and a display block. Let's call this constant output, and we can connect it to display. So every time, and then we can in this callback function, we define the set param function that sets the parameter. The name of this project was trial. No, the name of this project was demo. Demo/output. So inside the output, in the output block of Simulink project demo, we say that we set the value to object.return message. It has to be in single quotes as well. Yeah, so our system is set now, and hopefully the system should work. So let us check if the system is working. We have set up our system. We can have like an initial control loop to stop the system when it reaches a certain velocity. We can have a switch set up here, and the switch takes the position values, position degree, and it says that in case the threshold is less than 2200, we need to stop the system. So we can remove this for now, and we connect this. We have, it should be here, when we have two constants, one constant is 0 and the other constant is 30. So we have a value of 30. We have a rotatory speed of 30 when the position of the axis is more than 2200, but when it is less than 2200, it becomes 0. So in order to run the system, we need to have a broker, centralized broker. For my system, we are going to use a mosquito broker. So we can use any type of broker, but accordingly you need to set the address as well as the port numbers. So this broker is set up. You have, close this, you have this MATLAB function. Let's close this editor window, keep this open, go to the 3D printer and we activate the stepper motor. By doing this, we can get the inspector element here. We have our system here, and now we can see the velocity inputs outputs here and velocity input outputs here as well. So once I start this, I run this, as you can see the output values of the position are changing, and the velocity here is 30. So once it is below 2200, as in the switch case, it is turned to 0 and this stops. So thank you everyone, and good luck with setting up this integration yourself.